Chemistry videos, ionic compound naming. We need to remember that an ionic compound is something that is bonded between a metal and a nonmetal. And there are three naming rules that you need to follow. First, when we look at these elements, we must determine if they are the main group elements, or are they main group elements that are combined with a polyatomic ion. And if they're not a main group element, that means that they are in the transitional metal area. And if that's the case, we need to use the stock system. Now, if we take a look at the periodic table here, the main group elements are the ones that are in these tall columns. Okay? So these tall columns all through here are what are known as the main group elements. Okay? This area down here, this flat area, and these guys, which are known as the F block, these are here the D block, these are known as the transitional metals. We're going to start with the rule of main group elements first. Okay? So anything that's in the main group, any of these guys and any of these here are the ones that we're going to work with. Okay? So let's take a practice. Let's say that we're going to combine magnesium, which is in column 2, and we know that everything in column 2 has a 2+ charge, and we're going to combine it with another main group element. We're going to combine this with fluorine, and fluorine is in group 17. It is 1 away from the full complement of 8, so it will gain 1 electron, and we know that it has a -1 charge. So the first thing we want to do is create our compound, and once we get back into getting this back to neutral, we can see that it's going to take 2 of these -1 charges here to balance out the +2 on the magnesium. So our compound formula would be magnesium fluoride here. Now, if you're still questioning on how to make these bonds, please review the ionic bonding video. This one here we're going to work on naming. Now, the main thing that we want to work on here is that the main metal, the name stays the same. It is in a capital letter, so we'll write magnesium. Now the second element, which is fluorine here, we do not have to tell how many there are because it has only one type of charge here, as we can see. It only has a -1 charge and always a -1 charge. So what we would want to do, its normal name is fluorine, but when we're naming it, we drop off the INE and add an IDE. So the name of this is going to be magnesium fluoride. The IDE tells me that this fluorine is in an ion form, and that's how we would work with naming main group elements. We'll try one more here. Let's say that we're going to use something from group 1. Let's use potassium. Potassium has a +1 charge. Now let's combine this with sulfur. Sulfur has a 2- charge. I'm going to need 2 potassiums to balance this out. So once again, I'm going to end up with something that's going to look like this for my neutral compound. Now to name this, once again, potassium, metal first, capitalized, and the name doesn't change. Now the sulfur here is going to change just as we talked up above here. I got to drop the ending of it, so in this case, instead of writing sulfur, I'm going to drop the UR and I'm going to add the IDE. So what I'm going to end up here is potassium sulfide. And that's how we name main group elements. Now let's remember the polyatomic ions. So if we take any of the main group elements and we're working with polyatomic ions, it's the same thing except we would just use the name of the polyatomic ion. There is no dropping the ending. So if we remember our polyatomic ions here, we have ammonium, which is NH4 with a +1 charge. We have hydroxide. We have nitrate. And we have acetate. Those all have a -1 charge. Okay? Then carbonate is the one where we start to have a -2 charge, along with sulfate. And then we have phosphate. And if you're still worried about these, there is a video on polyatomic ions. These are the 8 you need to memorize. Okay? So, as I said before, the metal is always named first. Then, if it's a polyatomic ion, all we have to do is just add. So, if we have some practice here, let's take magnesium again, which we know has a 2+ charge. But this time, let's add to acetate. So, this would be called magnesium acetate, because I just take the name of the polyatomic and use it straight forward. If I try a different one here, let's say we're going to have calcium, which is a 2+ charge, and this time we're going to add it to hydroxide, which has a -1 charge. So here, I'm going to have to sit here and put this together. It would be calcium hydroxide. But my name would be just the same as always. It would be calcium, and then just name the polyatomic ion. So as long as we're going to use main group elements, the ones in the tall columns, if it's just another element by itself, we have to add IDE. But if it's with a polyatomic ion, we just name the polyatomic. However, if we're going to use transitional metals, oops, let me get rid of that. Okay, if we're just going to use transitional metals, and we take a look at this, remember our transitional metals are the ones that are going to sit in the D block here, and that would be in this big flat area. Okay, so these are all our transitional metals. And basically we want to kind of extend this and come over here to lead and bismuth and somewhere in here, and then all of these F block. Remember, down here is the F block elements in through here. Here, these can have different charges on them, and I cannot tell what the charge is on them until I see what they are combined with, or they give me it in a name. So we have to use something that's called the stock system, and the stock system is where we're going to use Roman numerals. Write that down here for you so you can see it. Roman numerals as in like 1, 2, 3, 4, 5, 6, okay, 7, 8, 9, and 10. Roman numerals, and if you get through 10, that's a pretty good set. The Roman numerals tell us what the charge is on the metal only. So it's on the metal that this is going to tell me what the charge is on this metal. So let's say that I have potassium, which has a +1 charge. Now, is this a transitional metal? No, it's not. So I don't have to use the stock system on this. But now let's say that I'm going to use copper. Copper is a transitional metal, and copper can have a +1 or it can have a +2 charge on it. We don't know until we see what the formula is or the name of it is. So if I see a compound that looks like this, or one that looks like this, I still have copper oxide. Okay, but I do not know what the charge of this is. Obviously, we know that every oxygen has a 2- charge. But in this case, there's only one copper here. So it must have, in this case here, it has to have a 2+ charge. But down here, I have 2 coppers. So that means this one here has to be a +1 charge for everything to balance out. So when we would name this one here would be called copper. And the charge on it is 2, Roman numeral 2, and then oxide, just like we had before. The rest of the naming rules stay the same. The only thing we have to change here is this right here to tell me what the charge is on that copper metal. This one here, copper 1 oxide. Now this is, it's kind of tricky, but it's not if you really just pay attention that all we're talking about here is in this one here, this is telling me copper 2 that I have copper 2. And this down here is telling me I have copper 1. Now this would be the same. Let me get rid of some of this up here, and we'll clean off some of my board here. And we'll do one more to give some practice, but this time we're going to use a polyatomic ion. Okay? So, what we'll do now is let's take a transitional metal that can have many different names on it, and we're going to use one that has this one very common one, is manganese. Okay? So, we'll use manganese, and we're going to combine it with the polyatomic ion of sulfate. Okay, so manganese plus sulfate. We know that sulfate has a 2- charge. We don't know what the manganese has on it unless we see a compound formula. So if I see a compound formula that looks like this, MnSO4, and this one here has 2 on it, and this one here has, let's say, 4 on it, then that's going to tell me what the charge on this manganese is. So this one here at number 1 is going to be manganese. We know that every one of these has a -2 charge, and I've got 2 of them, so this would be manganese 4. Sulfate. However, this one down here, okay, has 4 of them. We still know that every sulfate has a 2- charge. This is a total charge of a -8. So this one down here is going to be manganese 8. And that's how we can tell what the compound formula is. Now you're going to have to be able to go from compound formula to the name, or from the name to the compound formula. And it's very simple to do. Just remember that this Roman numeral here tells you what the charge is on the metal only, and that's only on transitional metals. Do this as many times as you possibly can. This is just a very small sample of ionic compounds, and you need to practice it over and over in your head. This is one of the main things on the mandatory pass exam coming up. So write down any questions that you have, so when you come in you can ask them, and remember to ask them, and remember to never ever ever give up. Chemists try, and stay gritty out there.